Alright, this is video number 2 for Ecology Who to Kill, our newest chapter for ecology. Our third chapter for ecology, in fact, so far this year. And this is a reminder of the problems we're going to focus on for the remainder of this chapter. And they are, how will species extinction impact a community of organisms? And number 2, and you can see it's highlighted because we're going to focus on it right now, it's how do our bodies use or lose energy? So thinking about the food we eat, thinking about wildlife and predator and prey in nature, in those communities and ecosystems. And also, what does it mean for a human society if we eat vegetarian only? So we weren't predators of animals, but only predators of vegetables and fruits. So this is a problem we will focus on in the end. But right now, let's look at and consider more about this problem. Let's think about it and try to learn a little bit. How do our bodies use or lose energy? So we're going to go on back to slide 6 where we left off. Slide 6 we discussed last video, but we did not finish it. We're going to watch this YouTube video, and then we are going to create a model to represent what we understand about it. And in the last video, we reviewed what it means to make a model, but if you've forgotten, just go ahead and pause the screen here and just study over this so you remember the importance of models and what we're doing when we make one. In short, though, it's a drawing scientifically to represent your own ideas, and we use symbols, and it always usually is supposed to show an effect before and after, cause and effect, but some kind of process or action. All right, we're going to move forward, though. We're going to play this video, and let's see what we can learn from it. All right. So this is a YouTube channel. It's called Science 360 News. It looks like it's paid for by the National Science Federation. So it's a legit site. Let's see what these ladies are up to. So you can see that this girl, it's for humor's sake, they're starting it, but they're running. And she's got the circuitries and these wires and device attached to her clothing. And the question is, why is she doing it? So, at universities, they're developing technologies and clothing that can absorb the body heat we produce when we exercise. And there are certain little devices that are flexible that can actually be woven into the material and absorb body heat. And that body heat, like you can see right here, this machine is showing you how much energy was absorbed by the special technology that's woven into the clothing. You can see it's a certain number of units of energy just from this guy riding this spin bike. So clothing that can absorb body heat and store the energy like a battery. So let's go ahead and look and see what they kind of look like up close. They're flexible, and they're called thermoelectric generators. But you can see that they're thick but not super thick, and they can be applied into the clothing material. And because they're flexible, hopefully it's comfortable, but they can absorb the body heat that you produce whenever you're just doing whatever you're doing in your day. And the idea would be is it could store enough energy to power something, maybe a cell phone, maybe lights on clothing during a bike ride to stay safe, anything, but like small electronics, which is pretty amazing considering the only thing that's making the energy is you from the food you've eaten. So let's play a little more. You can see it fitting here, or it can be worn in the form of an armband. Here's another example, another prototype a university working on, but it's an armband form, and it shows you that, it's a computer processing chip, it looks like, of some kind, and its job is basically to store body heat as energy, just like a battery. So to create this model, we're going to create a 4-step food chain. Now, it really isn't a food chain. We're going to pretend it's a food chain. But we're going to create a series of 4 images that link together to represent what we saw in the video and represent our understanding using some symbols or drawings, okay? Now, since I'm doing this on the computer, I'm just going to copy-paste some images, but follow along as I do this. So this is slide 8. So in your notebook, let's write slide 8, and let's create 4 boxes linked together with arrows. So this arrow links together these boxes, but you can see this is the beginning, and this is the end of what we understand. First, it says we need some food calories. So this being Burbank, we are going to get some Armenian dolmas. I'm going to copy that image, and I'm going to slap it right in here. And you can see, now, this is perfect. So I used an image or a symbol, and I used some simple words to say food calories, right? So we're not writing an essay when we do these, okay? Next, we need exercise. So I'm going to find an image for exercise. Just moving right along, but you can see it's visual. Models are visual. They're visual ways for you to draw something that shows a process. So we eat some food, we eat some dolmas, and then with the energy we exercise, and as we exercise, we produce body heat. And then we, of course, need something to capture that energy. So we have the little thermal electric generators in the clothing of this guy's shirt that is capturing the energy from the exercising, the body heat. And then finally, we need to store that energy inside the thermoelectric generator. So we need a battery. So I'm going to come up with a battery symbol. So if you see this, it's beginning to end. It shows a process. We use symbols, and it explains what we understood from what we learned. And in this model, it's a 4-step food chain. We're pretending it's a food chain, where it shows food calories go in. We eat the dolmas. We exercise using that energy. Our body produces body heat that's captured in the thermoelectric generators, and then the energy is stored for later use. So you can power technology, cell phones, anything, right? Okay. Our very first model of body heat in clothing. So just make sure that you write slide 8 in your notebook. You have the title Body Heat in Clothing Model, and then you have your image here, this drawing. All right. Feel free to use your own creativity. That's part of the fun of modeling, is making it fun and artistic. And of course, choose different foods or draw anything you want. Draw any kind of exercise, but keep it simple. Make a stick figure unless you're a really talented artist, okay? Otherwise, don't put so much pressure on yourself. All right, in your notebook, please write slide 10. All right, after you write slide 10, let's title this Cellular Respiration. Cellular respiration. And what that means is how the cells of our body use energy. Now, we're going to learn a lot more details in a later chapter. Let's think December or January. But for now, we just want to think a little bit about how our cells of our body use energy in the form of glucose or sugar, okay? It says the first task for slide 10 is to summarize what you learned. It says at least 3 sentences. So 3 sentences from the video I'm going to play, all right? So I'm going to play it, we're going to observe it, and I'm going to give you some hints. I'm going to talk a little bit about what I'm seeing, but make sure that you record at least 3 important things about the video, things we talked about, things that you think are important about how the body uses energy, when it uses energy, or things you see. You don't have to be an expert, just what you observe, just describe if you thought it was a main idea, okay? But 3 sentences. All right. So we can see this image here. It's an individual mountain biking. It says, as this mountain biker heads up the trail, the breakfast he ate this morning is being burned to power his bike ride. He breathes more, and his leg muscles demand more oxygen to burn more fuel. It says, let's zoom down to where this fuel is burned, our cells. So let's look at inside his legs, where the cells are going to take the food and breakfast he ate and turn it to energy. So we're going to zoom in to the cells of the leg. Zooming in more and more and more, and then we have some cells. Now you may not know, but muscle cells are long strands right here. So these long tube-looking things are actually what muscle cells look like. So muscle cells are long tubes that can change their shape a little when they have energy. They can contract or expand. They can get tinier or longer with energy. All right, again, in your notebook, make sure you write slide 10. So it says first summary equals someone's using blank to do the blank activity. So where did they get their energy from according to the description, right? What did the person eat? And it says someone's using blank to do the blank activity. So what kind of exercise is the gentleman doing, right? Okay. Now we're also ready to move on to the second summary. It says we zoom to cells found in the blank of the person's body. So where was it that we're zooming into? What part of the body are we studying? And we're not ready to finish this blank yet. So we're going to continue on, but we should be able to fill in this summary here with the first two blanks here and the first blank of the second sentence to summarize what we learned. All right, moving on. All right, again, these are muscle cells, and when I hit play, it's going to zoom into the left, and I'll pause it and explain what that is as well. So right here, this is supposed to be your blood. So this would be an artery. An artery is a part of your body. We think of everything as veins, but arteries are special tubes in the body that transport all that oxygen our body needs. So these little red guys are oxygen, and these black circular molecules are sugar. So it's glucose. So we have glucose and oxygen flowing through the artery, and that's a good thing. We want it to do that, and it's going to do something with it. So let's see. We got our muscle cells here, and you can see muscle cells have mitochondria, the powerhouse of the cell, yeah. So, and we have in the vein, we have glucose and oxygen. Oh, look what we have here. Oh, what just left the artery and went to the muscle cell? Well, you have some oxygen and some glucose. I think we're ready to finish our second summary. It says we zoom to the cells found in the leg muscles of the body, the leg cells, and we can see blank moving into the cells. Well, you saw two things move into the cells. You saw this and this. If you get confused, rewind the video and pick up where we left off. Or you can try to read this summary down here in the screen if your eyes are good enough and your screen's big enough. All right, so we got summary 2 finished. Now we need to get the third one. It says the blank enters cells and is transformed into blank. All right, so I hope you're on the edge of your seat. Let's see what energy happens to, okay? So the glucose and the oxygen have just entered in, and boom. It released these little star things. How cool is that? So let's replay this. So glucose enters in, and it releases the stars. We don't know exactly what stars are, but let's call them energy, okay? So it looks like in the muscle cell, the glucose goes straight to the mitochondria, and then the mitochondria takes the glucose and oxygen and makes some new things, including these bright little energy blasts, okay? So it says the blank enters cells. We can put glucose or oxygen, and it's transformed into, and then you describe what you saw. What would you want to call that was released out of the mitochondria? You can go ahead and rewind it and replay if you need to. All right, next question for slide 10, so number 2. So you should have 3 summaries for number 1. And then number 2, it says, why do some students after a workout complain the room is too hot? So number 2, you should write hypothesis equals. All right, it says your answer should be a hypothesis. So it says hypothesis equals room is too hot because, why do you think? Why do you think after someone works out, the room they think is too hot? All right, last question for slide 10, number 3. It says, what was your hardest workout? All right, so the last question, number 3, you would write, my hardest workout was when I did blank. Be detailed. I'd love to hear something you've done that was crazy hard, if in fact you've had a chance to do something big and challenging, okay? All right, we find ourselves here on slide 12. And let's see. First, it says arrange in order of lowest to highest energy amounts. So we need to look at these 4 different food items. We have broccoli, apples, oatmeal, and chicken breast. We need to look at the calories here so that we can decide which ones have, and calories here for here. Okay, so calories for the chicken is right there. So broccoli has 30, apples have 80 calories, oatmeal has 607 calories per serving, and the chicken breast has 170 calories per serving. So we need to start with the item that has the lowest number of energy calories. So for question number 1, you would write first in your notebook, slide 12. Then you would say 1. And then which thing here has the lowest number of calories? Which thing here has the next lowest? So broccoli has the lowest, it's 30. And then the next thing would be the apple. So a single apple has 80 calories. So we would put 1, we would do A, comma, B. And then the next thing would be D, because the chicken breast only has 170 calories. So we put comma D. And then the final thing, the thing with the highest level of energy, would be the oatmeal at 607 calories. It has way more calories. Now, lots of carbohydrates in the oatmeal, and those carbs provide lots of energy. So the order is for number 1, A, B, D, and C. Next it says How many servings of broccoli would you have to eat to total that? Well, we'll find out in the next video.